record this. Okay. So if complex number is z, the conjugate is z bar. And both of these have a real piece and an imaginary piece. Okay? So, example 1, write in standard form. Standard form means it should be a real piece plus or minus the imaginary piece. Okay, and our expression is 2 over 3 minus I. Is this currently in standard form? Is it a real piece plus or minus an imaginary piece? No. So we need to break it up a little bit. There's also some things we don't ever like to leave in our answers. We learned with exponents this year, we never leave negative exponents. We also don't like to leave square roots and denominators of fractions, so we have to rationalize the fraction. We also don't leave i's in the denominator of the fraction. So, we've done this before. It's been like a month or so. To get rid of the I in the denominator of the fraction, it's been a long time. Does anyone remember how we do that? Multiply by the conjugate. That's the little trick. This conjugate is a very useful trick. Okay, if the binomial, the complex number, I guess we shouldn't call it binomial, but it looks like a binomial, 3 minus I is the complex number. Aaron, what would the conjugate of 3 minus I be? So if that's the original, the conjugate just changes the sign. Yep, so it'd be 3 plus I. But if we times it on top, we have to times it on bottom, because 3 plus I divided by 3 plus I is 1. So we're not actually changing the problem if we're timesing by 1. Okay, so we're going to go through and distribute it in and see what happens. If we distribute the 2 in, we get 6 plus 2i. Do you agree with that? 2 times 3 is 6. 2 times I is 2i. Okay. Would you on your papers go through and do double distribution on our complex number and its conjugate? Multiply those through. Multiply them through. Did you do that? Keep going. Good. I times I, isn't that? What's I times I? Oh, and it's actually negative I times positive I. What would that be? That would be, you're thinking adding. Negative I times I. Negative I squared. Yeah? Okay. Let's see what we got. Andre, what'd you get? You should get 4 terms that pop out. 3 times 3 was 9. Then 3 times I was positive 3i. Negative I, make sure you use that as a negative I, times 3 is negative 3i. And negative I times I is negative I squared. By using the conjugate every time, these middle ones will cancel. By using the conjugate. So on the top we have 6 plus 2i. Do you remember what I squared is? Good job. It was negative 1. So this is really 9 minus a negative 1, because it's minus I. Or in other words, 9 plus 1, which is 10. So I have 6 plus 2i over 10. I want it written in standard form, which is the real piece, plus or minus the imaginary piece. So now I'm going to break, now that I have one denominator, I'm going to break it apart. 6 over 10 is the real piece. What's the imaginary piece? 2 over 10 I. I'm going to stick the I outside. And if I simplify, both of those simplify. 6 over 10, yeah, and what would that simplify to? 3/5, great. Plus, Sammy, what does 2/10 I simplify to? 1/5 I, right? And now that's standard form. We have a real piece, which is the 3/5. And we have the imaginary piece, the 1/5 I. Any questions on that? Okay. And try another one. This is review. We've done this. It was a little tedious. Back in the day, it's been probably over a month since we've done it. It was good to go back. We have 5 plus I, this is example 2, over 2 minus 3I. Same directions. We're going to write this thing in standard form. Also, notice what we did with the conjugate. By using the conjugate, was there an I in the denominator anymore? No, it pushes it up to the top, which is what we want. Okay? So we have an I in the denominator right now. We need to push it up to the top. So how do we do that? What did we do on the last problem? The conjugate. You're going to times top and bottom by the conjugate. Okay, Edith? What's going to be the conjugate? Because we have 2 of them, right? Which one are we trying to change? This one? Minus. Well, we're trying to, this denominator, 2 minus 3I is the problem. Because it has the I in the denominator. So we want to do the conjugate of the denominator, which would be 2 plus 3I. Top and bottom, we times 2 plus 3I. It's the same thing, except for it's plus. 2 plus 3I. Okay? If you have used the correct conjugate, you should see the middle terms, like this last one, canceled out. Okay? In the denominator. Would you go through and distribute? Now, put some parentheses around 5 plus I and 2 minus 3I. Go through and distribute the numerator through and the denominator through. You should end up getting 4 terms on the top and 4 terms on the bottom, and a couple of them will end up canceling out. You need to do one more. Negative 3I times positive 3I, because you need 4 on the bottom. Okay. Good job. That's right. Okay, thanks. Alrighty, on the top. Kayla? What did you get on the top when you multiplied 5 plus I times 2 plus 3I? Okay, so that's the 5. Now you need to distribute the I in. I times 2 and I times 3I. Plus 2I. Good. So I times 3I is 3I squared. because I times I will be I squared. In the denominator, Chris Rowan, what'd you get in the denominator? Minus, because negative 3i times positive 3i is minus 9i squared, because negative 3 times 3 is negative 9i times I is I squared. Okay, do we have any cancellations? Yeah, right here, as expected. Those should cancel. If they're not canceling, you're doing something wrong. Okay, so the denominator becomes 4 minus 9. What is I squared? So times negative 1. And the numerator, what do we do in the numerator? We have like terms. In the middle here, we have 15 ice creams plus 2 ice creams is 17 ice creams plus 3. What is I squared? So whenever there's an I squared, it becomes a real number. It's no longer imaginary. I squared is negative 1. So we actually end up having 10 plus 17i minus 3 on the top. And we have 2 more, apparently a crazy eye smiley face, like term. And on the bottom we have 4 plus 9. Any questions how this became like negative 3 and this became a positive 9? Because of the I squared. Okay, so we have like terms, 10 minus 3. What's our real part for the numerator? 7 plus 17i, and the denominator, 4 plus 9, is 13. Now the I is no longer in the denominator, and we can see the real piece and the imaginary piece. Okay, Hunter, Lawrence, what's our real piece? Yep, 7 over 13, plus, Hunter, what's the imaginary piece? 17, it's still a fraction, over 13i. Yeah. That's standard form. The real piece plus imaginary piece. Okay? Any questions on that? Let's review. Hopefully it feels a little easier than it did a month ago when we did it the first time. All right. Now we're going to go back to quadratics and start solving quadratics. It's related, I promise. Example 3. Solve the following quadratic. X squared plus x plus 1 equals 0. X squared plus x plus 1 equals 0. Okay, when I say solve, what does that mean we're finding? Okay, what is a solution of a quadratic? X-intercepts, which are also called zeros, which are also called roots. On the graph, it's the x-intercept. Okay, you first go to, when solving quadratic, the easiest method is factoring. Can you think of two numbers if we were to factor? What goes on the top? 1, first times third. 1 times 1 is 1. And we look to add to 1. Can you think of two numbers that multiply to 1 and adds to 1? 1 times 1 adds to 2, though.
2 times
But it has to still multiply to 1.
half. An imaginary number.
It is an imaginary number, actually. Because are there any real numbers that exist? No, it's not going to work, so we can't factor. This is when our friend the quadratic formula comes into play. Let's sing our song. X equals, how does it go? Negative b plus or minus square root b squared minus 4ac all over 2a. Get this formula memorized if you don't have it memorized. We have to identify a, b, and c. Another option we could do if it doesn't factor nicely is completing the square. So both of those are the go-tos if it doesn't factor nicely. Okay? A, B, and C. Andres, what is A, B, and C from the quadratic? So it's the coefficient. How many x squareds are there? Now what's the number in front? Yeah, 1. Okay, and B, how many x's are there? 1, and C? 1. So they all end up being 1s. And 1s are pretty nice to work with. So let's plug it in. X equals negative B. So what do I write? Negative 1 plus or minus square root. In parentheses is B squared. What's B squared? 1 squared. Minus 4 AC all over 2A. Everything was a 1 that we plugged in. Except for the minus 4 is part of the formula. Underneath the square root, there's a vocabulary word that starts with a D for the simplified form underneath the square root. What is it? Discriminant. There are 3 things that happen. If the discriminant is greater than 0, meaning positive, what type of solutions do we get? 2 real, because we can graph them on the x-axis. If we have the discriminant is less than 0, taking the square root of a negative, what does that give us? No reals, but there are 2 complex imaginary solutions. And the other option is when it's equal to 0. We have 1 real solution and not 1 complex. It just means there's going to be a repeated, and we're going to talk about the multiplicity of repeated root a little bit today. Okay, so let's do the discriminant first. We'll go this way. Doing exponents, what is 1 squared? 1 squared is 1. Negative 4, make sure you remember that's a negative. That's an easy mistake. People do a positive 4. Negative 4 times 1 times 1. Negative 4. All over 2. Still working inside the square root. What's our discriminant number? Negative 3. So it's a negative. So what type of solution should we get? 2 imaginaries. Okay? So when we get 2 imaginaries, the square root of negative 3, that pops out an I. Negative 1 plus or minus. Now some people put the I after, I don't know. I don't really like doing the I after the square root because if you do the square root line too long, it looks like it's underneath. It's supposed to be outside, so I'm going to put it in front. Square root, if you pop out the negative 1, it would become plus or minus I root 3 over 2. Is there a real piece and an imaginary piece to this? Yeah. The real piece is negative 1/2. Negative 1 over 2. What's the imaginary piece? Plus and minus. It's not just 3. It is root 3. Root 3 over, don't forget, still a fraction. What's its denominator? 2. And then on the outside, put the I. Oh, we popped out the negative 3. If we did a factor tree on negative 3, we get negative 1 and 3. And the square root of negative 1 is I. So it pops that out to the front as an I. And then it leaves just a positive 3 behind. Yeah, good question. Okay, so we get 2 answers. And they're actually conjugates of each other. One of the answers is x equals negative 1/2 plus root 3 over 2i. What's that's conjugate? All of these complex numbers have conjugates. What's the conjugate? negative 1/2 minus root 3 over 2. So when we get two imaginary solutions, they're going to be conjugates of each other. Okay, there's actually, if you have your book, would you open up your book to page, the honors one, the volume 2 one, to page H43. It's in the back where it has that really solid dark strip. Dark strip is the H43. On the bottom, there's Theorem 102. H43. Show your neighbor if they didn't bring theirs. H43. It's in the back where that dark strip is. Theorem 102. I put it on the text, so you were supposed to bring it. So suppose that f of x is a polynomial with real coefficients. If a and b are real numbers, la-di-da, and a plus bi is a 0, meaning an x-intercept, okay, it says if a plus bi is a 0, meaning an x-intercept, what must also be a 0? It's in the bluish-green box at the very bottom. Page H43. H43, Theorem 102. H43. A plus bi is a 0 of f of x, then it's what is also a 0? It's conjugate. It's complex conjugate. So a minus bi equals x. Okay, they come in pairs. If you have one, then there exists the conjugate version as well. Okay, so make sure you get 2. All right, let's try another quadratic formula. Example 4. Solve. X squared equals 5x minus 17. X squared equals 5x minus 17. Brayden, how would we start to solve this? So we want a full standard form? So that one side is what number? 0. We need one side to be 0. And we want it to be positive x squared. So x squared is already positive. So it's going to claim the left side. So we need to move everything to the left side. It's easier to work with a positive x squared. You can go with negative if you want, but you're just making your life miserable. So let's work with the positive x squared. How do I get everything to the left?
Subtract and add.
Subtract 5x, add 17. But we need to do it on both sides. Subtract 5x, add 17. So on the right, those cancel and we have 0 equals. Now put it in order. X squared first, the quadratic term, the linear term, the constant term. Alright? Can you think of two numbers that multiply to 17 and add to negative 5?
No.
The only thing that multiplies to 17 is 1 times 17 or negative 1 times negative 17, right? Do either of those add to negative 5? Not a chance. Which means we should do the quadratic formula. Alright, I'm going to let you try this one. So, find your A, B, and C. Plug it into quadratic formula. Simplify the discriminant carefully. Okay, I'm going to go through it really quick. You're probably already to this point. A, B, and C was 1, negative 5, and 17, right? And we plug in and we get negative 5, which is positive 5. Plus or minus square root. I saw lots of people using parentheses around that negative 5 squared, which is awesome. Minus 4AC. Make sure the square root sign goes all the way across. All over 2a, and this, of course, equals x. Underneath the square root, we work with the discriminant. exponents first. We get 25 minus, what was it, 46?
68.
Oh, wow, that was wrong. 68. Minus 68. All over 2, which equals 5 plus or minus square root negative 43 over 2. Okay. Negative 43, you have to check, see if it's going to break down. Factor trees from way back in the day. Negative 1 and 43. Does 43 break down? Because it's prime, right? But you need to check. Sometimes things pull out. In this case, one thing does pull out. What pulls out? An I, not negative 1. Square root of negative 1 becomes an I. So we get I root 43. Okay, so this becomes 5 plus or minus I root 43 over 2. But we'd like you to write in standard form with the real part plus or minus the imaginary part. Okay, Sean, what's the standard form of this one? What's the real part? 5, it's not just 5, it's 5 over, so 5 halves, okay, plus or minus, so I'm going to put the I at the end. Okay, I need one more thing. No, I need the square root. So the square root, 43 over 2. And the square root only goes on the 43. It does not go over the 2. So don't extend it down. It's just in the numerator. Okay, is this showing 2 complex solutions? Is it showing 2? Yes, because of the plus and the minus. That's showing 2. So this equals x. Okay. Alrighty. I'm going to give you one more to solve. Once you're done, we'll take a quick little break. Example 5. Solve again. Oops. Oh. Okay, that was different than how I wrote it on my notes, but that's okay. I just changed the equation. Still works. Okay, 3x squared plus 10 equals 4x. Is it set up for quadratic formula?
No.
No. Is the x squared already positive?
No.
So we're going to move everything to the x squared side, which means subtract 4x. We need the x squared to be positive, so I subtract 4x. Write it in standard form, 3x squared minus 4x plus 10 equals 0. All right. Solve it, please, meaning finding the x-intercepts or solutions. If our solutions are imaginary, are they actually going to cross the x-axis? No. So sometimes our solutions aren't actually x-intercepts. Okay, once you checked it off with me, then you can stand up, go get a drink if you need to. We'll take a little break. But I want you to check it off first. Here's a hint. You definitely are going to have to break down the square root with a little factor tree on this one. Okay, let's just make sure everyone's comfortable breaking down square root negative 104. The negative, remember, is a negative 1. Negative 1 times positive 104. How does positive 104 break down? 2 times 52. 52 breaks down into 2 times 26, and we get 2 and 13. So all of these are factors underneath the square root. Negative 1 times 2 times 2 times 2 times 13. What pulls out? We have one pair of 2's, but one of them stays behind. So we pull out a 2. What else pulls out? An I. This negative 1 pulls out as an I, leaving behind 2 times 13, which is 26. So this will be plus and minus when you do the root. Okay, hopefully that helps you. When you think you have it, let me know. I'll come check. And you can go get a drink if you need. Okay, find your seats. I'm going to fill in what you guys checked off. You got to, let's see, x equals 4 plus and minus the root negative 104 over 6. We changed root negative 104 to, we popped out a 2 and an I, root 26, right? The real piece is 4 over 6. Plus or minus the imaginary piece is 2 root 26 over 6 with an I on the outside. Okay, put your phones away, please. You have to make sure you simplify these. That's what I told most people. 4 divided by 6 is 2/3. Now here's the tricky part. When you simplify this one, the 26 does not change. It's just the coefficient that needs to be simplified. 6 simplifies to what? 1/3. So the root 26 is going to stay root 26. Over, you can put a 1 if you want. We don't really need it. Over 3, and that's an I. And those are 2 imaginary solutions. Okay? Any questions? Most people just got to the part they just need to simplify. All right. Now, new directions. That was example 5. Here's example 6. Write the polynomial function in standard form and identify the zeros and x-intercepts. Right, the polynomial function in standard form and identify the zeros and x-intercepts, yeah? But it's going to look different. I'm going to give you something that looks like this. X minus 2i and x plus 2i. So there's actually 3 parts to the question. Standard form, what are the zeros, and what are the x-intercepts? Well, close to the same thing. You'll see. Oh. There's always exceptions, right? Yeah. I before E except after C and in the word weird. Because it's weird. All right. These are factors. Okay. We can find the zeros applying the zero property, right? Zero property, remember, means we take each individual factor, set it equal to 0, and solve it. Take the other one, set it equal to 0, and solve it. Oh, those are your quizzes? We need to get those in the folder. All right, solve both of those and find the zeros. Yeah? Okay, you'll have to do it. Hang out for a minute during lunch. It only takes a minute. Okay, what is this one going to be? X equals positive 2i. If you've noticed a nice little trick, it's just the opposite sign. And this one is x equals negative 2i. Or we could say x equals plus and minus 2i. And those are the zeros. Plus and minus 2i. This is the zero property. You can take the factor, x minus 2i, set it equal to 0. If you're solving for x, wouldn't you just add 2i? Positive 2i. This one, you would subtract 2i, so we get negative 2i. Okay, those are the zeros. But the zeros are imaginary. So where's the x-intercept? Nowhere. If it's an imaginary, it doesn't cross the x-axis in the real coordinate plane. Could in the imaginary, not the real coordinate plane. So in this case, the x-intercepts, the x-intercepts are none. Okay, so we have zeros, but they're imaginary zeros. So the x-intercepts, we have no real, or you could say no real x-intercepts. Or none. You can do either. Okay, so we've answered two part of the questions. The last part of the question is, what is standard form? So I think to avoid getting things really messy, we should just rewrite the function. Standard form means it should be in descending power, ax squared plus bx plus c, your quadratic, linear, constant term. How do we take these two factors and make it into standard form so it looks like a polynomial? Distribute. Yeah. So shout it out. What's x times x?
X squared.
What's x times positive 2i?
2xi.
Plus 2ix. And what is negative? Make sure this is a negative. Negative 2i times x. Minus 2ix. And negative 2i times positive 2i. Negative 4i squared. These factors, what's a vocabulary word to explain what the factors are? It starts with a C. Conjugates. One was plus, one was minus, but everything else was the same, which is why these two cancel out. Okay? So the standard form is f of x equals x squared minus 4 times, what is I squared? Negative 1. So negative 4 times negative 1 is just positive 4. This is standard form. And by the fundamental theorem of algebra, which is in your book, page, you should already be there, H42, Theorem 100. Are you on H42? Theorem 100. Fundamental theorem of algebra, what does that say? Okay, a degree n has n, what does it say? N what? N complex zeros, which could be real or non-real. What's the degree on x squared plus 4? What is the degree? 2. So there has to be 2 zeros. They can be real or non-real. Did we get 2?
Yeah.
Yes. Okay, this is an example of a quadratic, because it was x squared. Now we're going to do a cubic. Same directions. Cubic means I'm going to have 3 x's. X times x times x, which should be an x cubed. So, f of x equals x minus 5 times x minus root 2. Guys, the root 2 ends. The I is not underneath the root. Don't extend your root line. It's not underneath the root. And if there's this complex root, then there has to be its conjugate. What's its conjugate? X plus root 2 I, and that I is not underneath the square root, so make sure you're very careful. Notice there are 3 x's, so this is a cubic, because there are 3 x's. Let's start by finding the zeros and seeing which one of those zeros are actually going to be x-intercepts. How do we find zeros? Zero property. We take each of the factors and set it equal to 0. 0 equals x minus 5. What's that one going to be? Positive 5. 0 equals x minus root 2 with the I outside of the root. Can anyone just see that one without doing inverse operations? It will be positive Because if I add root 2i to both sides, I get x equals positive root 2 with the I outside. And this last one, if I set it equal to 0, x equals negative root 2i, which makes sense because these guys, these imaginary ones, they have to come in pairs. They have to be conjugates. One will be positive, one will be negative. Their real part is just 0. This is 0 plus root 2i. This is 0 minus root 2i. They have to come in pairs. Okay, so out of these are our zeros. But out of these, which one is actually an x-intercept on the real x-axis? Yeah, so our x-intercepts, we only have one x-intercept. It's x equals 5. Okay? Our zeros, we have 3 zeros, but only one of them will actually touch the x-axis. Okay? So we've answered 2 of the 3 questions. The last question is, what is the standard form? So I'm going to rewrite it. F of x equals x minus 5 times x minus root 2 with the I outside. Make sure that I is not underneath the root. Standard form. How are we going to get it into the form x squared plus an x plus a constant? Distribute. Here's a trick. If you want to make your life easier, distribute the complex roots first. If you want to make your life easier, do the complex first because they're conjugates and those middle terms will cancel out. So x times x is x squared. X times root 2i is just a positive root 2i x. Negative root 2i times x is just negative root 2i x. And those two will cancel out. That's the nice thing about conjugates. And then lastly, be really careful. Negative root 2i times positive root 2i. What is a negative times a positive? A negative. What is root 2 times root 2?
Root 4.
Root 4. We could go with that for a minute. And what is I times I? Squared. So that says negative root 4i squared. Well, root 4 is just 2. So we have minus 2, and I squared is negative 1. So this becomes x squared plus 2 because negative 2 times negative 1 is plus 2. Don't forget, we had an x minus 5. If you do the conjugate first, it won't be so bad because those middle terms will cancel out. Don't forget to change your x squared or your I squared to a negative 1. Now if we factor these through, or not factor, distribute them through, x times x squared, it's a cubic function, like I said, x cubed. We should get a third power. X times 2 plus 2x. Negative 5, make sure you use the sign. Negative 5 times x squared. Negative 5x squared. And negative 5 times 2. Negative 10. So our last thing is this in standard form? We have a little bit of an order issue. So we'll just reverse the order. The x cubed. What's the sign on this 5? X squared? No, what's the sign? It is a negative 5x squared. Positive 2x minus 10. That is standard form. Okay, we're going to do one more example. for your homework. I told you it was long. That's why I gave you a break in the middle. Okay, so this is example 6. Lucky number 7. Example 7, different type of problem. Find a polynomial given the following zeros. -3, 4, and 2 minus I. -3 and 4, are those real or imaginary? They're real. What's 2 minus I?
Imaginary.
It's imaginary. It's a complex number. But complex numbers come in pairs, so they didn't give you this one, but there is one more root.
2 plus 1.
No, 2 plus I. You have to know that these come in pairs. So we also have to add in this conjugate, 2 plus I. Even though they don't give it to you, it comes in pairs. You need to use the conjugate. So this is reverse order. This time you have the zeros, you need to get to the factors. Look how we did it on this one. Where is it? X minus 5, we said the 0 was positive 5. So if I gave you 5, going reverse, you would say x minus 5. You use the inverse sign. If this is positive, you would use minus. Okay? So for our function, f of x, if the 0 is x equals -3, what's the opposite sign of negative? Plus. So our factor will be x plus 3. It's reverse of how we've always done it. If this is 4, it's a positive 4. What's the inverse sign? Minus 4. So we write x minus 4. Those are the easy ones. Are there any questions how we're getting these two? You just use the inverse sign. You make it a binomial. X plus 3, x minus 4. Next one. Takes a little brain power, but it's the same idea. What's the sign on that 2? Positive. So the inverse sign is negative. So this one is still an x. I'm going to use a bracket, actually. X minus, because you said minus, because 2 minus I as a group. It's the same thing. You told me 2 was positive, so we're going to do the inverse of that, minus it. X minus the group, the complex number 2 minus I. This one, what's the sign of 2? Positive, so we're going to write x minus, because the inverse of positive is minus, in the grouping, 2 plus I. That's the setup. To find the answer, I think we have this really quick. You need to multiply everything through. I would do these two binomials together. That's the easy part. X times x is x squared minus 4x plus 3x minus 12. Keep in mind this is timesing to the next stuff. So we have like terms. What's negative 4x plus 3x? Negative x minus 12. That's the nice one. These ones are actually really nice too because of the conjugate. X times x is... Okay, now keep this in the parentheses. X times negative 2i is a negative x times 2 plus I. I didn't say the plus, but... Now we have negative 2 minus I times x. So we have a negative x times 2 minus I. And negative 2, we have a negative times a negative, which is a positive, and we end up getting 2 minus I times 2 plus I. At this point, we'd have to go through and multiply all these through and find like terms. We're running out of time, so we can't do that today. So Next, on your homework, you have a couple like these on your homework. The hardest part is setting it up, using the opposite signs. And if you want to bring questions next time on how you go through these, I'll be more than happy to answer the questions. The homework is in the honor section of the book, so make sure you take the honor section home. Just a minute. The honor section we have, where is it? I wrote it down. H35. This is the review. These ones are review. The second page is the new stuff. 2 through 20 even. So the H47 has, use the quadratic formula. You guys were doing pretty good with that. It wasn't too bad, right? Using the quadratic formula, getting two imaginary solutions. It's just the last couple of these. You'll probably want to bring questions on next time, because it's like the last example we were just doing. Okay? We have tutoring tomorrow after school. Miss McDonald's room, 121, if you want some help with this. Or you can even stop in today after school. I'd be cool with that as well. Bring up your calculators in order if you would, please.